All right, so now let's do quadratics number 3. And quadratics number 3 is factoring x squared plus bx plus c. X squared plus bx plus c. So first, maybe a little bit of orientation, just what is x squared plus bx plus c. Later, we're going to put an a in front of the x squared, so there's going to be a capital A, B, and c. They represent numbers that can be plugged in prior to the x or as a coefficient of the x. And then a tail term, which would be a constant, can be added with the c. So you'll see this format. It's just a format explanation. So the first one we get is x squared plus 13x plus 42. All right, first things first. Do you still have your phone out? Can you see it from there? Can you go to photo math? If I write it large enough, then you guys can go ahead and just do it from your seat, huh? So look how cool this is. Not only, here if I can show it to the class a little, not only does it factor for her right here, here's the factoring, right? But look what it does. It graphs the parabola. So all that, just that, and you can almost do it from your seat from the board, right? So not only do you have the factoring, but you've got the parabola being drawn. That's the actual graph of this function. All right, so let's go through the manual. I think you're using the technology to go, what's the answer? Now I do need to understand a manual process for this. I would love for you to know that, right? I don't think as an engineer or a scientist or whatever it is you're going to do in life, you don't want to just trust the technology to do things for you. You want to use the technology to save you time, but your brain needs to understand, is this right? Did I, is this thing giving me the correct calculations, right? The engineer designing the bridge just wants to back up the device's calculation with their own calculations. So we don't want the bridge to collapse and then somebody come back and go, did you check them manually? And you're like, no, I just plugged them into the, the program. That's not good, all right? So how do we do this? First things first, you need to have some sort of basis for, hey, this is a quadratic. It backs up into two binomials being multiplied. There is some sort of understanding that you know where you're headed. And that's why being able to even write this, 2 sets of parentheses, where I'm setting up a binomial here times a binomial here. This knowledge of your brain being able to go, I know I'm headed back to this, takes a little bit of experience of just looking at these going, where are we headed, right? All right. With that said, now we don't have a lead term here, which we'll see later, and that can complicate it a lot. We know we have an x and an x. So we know that x times x, when we do that first, it's going to have to produce the x squared. So we already know our binomial has an x and an x. This becomes a little bit more complicated. How do we get a 42? In our FOIL process, we end up multiplying those tail terms, or the last terms in both binomials. When we multiply, whatever we get comes out here in the tail because there's no x's attached to it. It's just a constant, right? So how do you factor 42? What are some factorings of 42? What 2 numbers can you multiply together to get 42? How about that? 6 times 7, I like that. And a lot of times, if we start to have lead coefficients, you might have to write this 2 ways. You might have to say 6 times 7 and 7 times 6, because depending on what else is going on, if there's a lead term here, the placement of whether the 6 is here and the 7 here, or the 7 here and the 6 is here, will start to complicate things, right? So we write it both ways. What else you got? What else can produce 42? What else? What else can produce? What 2 numbers multiplied together can produce 42? What other options you got? How about this? 1 times 42, right? Don't forget the obvious. I know you know the math, but don't forget it. And you can reverse that and have 42 times 1. How about what's half of 42? 21. So you could have 2 times 21, or 21 times 2. See my whole list of factors now for 42, right? And I think that's all at the moment, unless I'm forgetting something. I don't think I am. So now you look at the center term. If you remember when we did this CLT process. We combined like terms to produce this. So you're asking which 2 of these add up to equal the center coefficient here. For example, 21 plus 2 equals 23. Is that 13? Say no. No, it's an obvious question, right? I'm looking for an obvious answer. 2 plus 21 is 23. Again, it repeats. No. 42 plus 1 is 43. Does that equal 13? Out. Out. 7 and 6 is 13. Go like that. There we go. Nice. Okay, I didn't get any sound, but I got the hands. That's just as good. That's awesome. Okay, so, and in this case, because these 2 add up, right, to equal 13, we're going to put a plus 7 and a plus 6 here. Does that match our phone answer? Does that match our photo math answer right now? X plus 7 times x plus 6. Okay. Did they write x plus 7 times x plus 6 or x plus 6 times x plus 7?
X plus 7, x plus 6.
All right. So just so you know, these could be reversed. Just like 5 times 3 is 15 and 3 times 5 is 15. These could be reversed, and so they may show it a different way than us. We still have the same answer. What do you want to do? You want to go through the FOIL method, and you would like to check it. So do the first, outside, inside, and last. X times x is x squared. 6 times x is plus 6x. Plus 7 times x is plus 7x. Plus 7 times plus 6 is plus 42. Notice the CLT happening. 6x plus 7x is 13x. The 42 comes down, and the x squared is out here. Does this look like the original? Yes. Check. Fair enough? So, do I need to prove that these can be swapped? Maybe. But let's think about one that's more complicated. In fact, let's take this same one. All right, ready? So we're going to factor this now. We know it goes into a binomial times a binomial. We know there's an x and an x. Now we're going to do the same thing of mapping out the factors of 42. Since we've already done it, we're going to use the list. We said 21 plus 2 was 23, right? Well, now the plot thickens. Notice the negative in here. A negative means that somewhere we might actually be subtracting these. What's 21 minus 2? 19. Okay, those are out and out. We don't like either of those. What's 2 minus 21? It's a negative 19. And 42 minus 1 is a 41. Out and out. I'm looking for a negative 1. That's what I'm looking for. Not all these numbers I got here. So what's a 7 plus 6? 13. And I like that because it hit this. But what's 7 minus 6? A plus 1. This is out and this is out. What's 6 plus 7? A 13. We said that was out because we're looking for a minus 1. What's 6 minus 7? Minus 1. So something's going on with this, but I need the 7 to be a negative 7. Because a negative 7 plus 6 is going to produce that negative 1. So what do I drop in here? I drop in the minus 7 and I drop in the plus 6. So that looks a little strange. And notice notice the small shift, just a sign change from the prior problem. That's it. That's all that's changed. You've got a negative here. Otherwise, this looks exactly like this. So your eye's going to have to be a lot more detailed when you look at these. You're looking for not just numbers, but you're looking for signs also. So let's do the FOIL. First is x squared. Outside is plus 6x. Inside is a negative 7x. Last is a positive, wait, why did I do this? I'm so sorry, you guys. I'm getting ahead of myself. I wanted a negative 42 in there. And that's why when look, I'm getting too fast and loose with this, and I apologize right off the bat, okay? The 6 and the negative 7 need to multiply to equal a negative 42. I'm getting ahead of myself, and I'm not happy about that one bit, all right? So the negative 7 times the positive 6 has got to be a negative 42. When you factor, go ahead and can you see, do one with your photo math and focus on this one up here. Can you zoom in and out on that? Like if it's far away, can you zoom even? No? Okay. Okay, good. Plus 6, see my x plus 6? See my x minus 7? Do you see how they put theirs up front? Right? They put their x minus 6 or x plus 6 up front and the x minus 7 put in back. So what the two things that I neglected to do to try and go back and repair this a little bit. Not only do they have to multiply together, so 6 times 7 would be a positive 42. So one of them has to be negative. It could be negative 6 times a positive 7 is a negative 42, and that would match up here. So that's one option. And the other option would be a negative 42 here, a negative 7. So I need one of those values to be negative. When I add them now go to the add route. Negative 7 plus 6 equals a negative 1. 7 minus 6 equals a positive 1. Because I've got the negative 1 here, that's the one that's going to match up. It's got to be this one, x minus 7, x plus 6. Combine like terms, negative 7x plus 6x is a negative x. The minus 42 is still on the tail, and the x squared is here, x squared minus x minus 42. Okay, so I'm not happy about that, but I want you to not only practice with photo math, but I want you to go back and practice with factoring this one and factoring this one and see if you can duplicate the results, all right? Let's see what else is in here. So binomial we know about. Trinomial is 3 terms. We know about FOIL for checking and CLT combined like terms. All right, let's go ahead and stop there.